shape of f of x. So we see f prime of x is negative 2, which is always negative. Therefore, f is always decreasing. Okay? This one also, no matter what I place in for x, it's going to be negative because you square the x, and then you take the opposite of that, which is going to make that whole thing a negative number. Subtract 1 from negative number, so therefore always negative. So therefore, the only thing we can tell about f is that it's decreasing. Okay. Likewise, f prime is x squared plus 1, which is always positive. Therefore, f is always increasing. Okay. And again, for the first three, f is decreasing, decreasing, and increasing for all values of x. Okay. Here again, x squared plus 3 is always going to be positive. 2 is always positive, so therefore f prime of x is always positive, so therefore f is always increasing. And I should say for all x, that upside down capital A means for all x. Okay. Then we get to this f prime of x is equal to x times ln of x. Well, first of all, the domain of this is x has to be greater than 0. So if x is greater than 0, then this is always going to be positive. And we know that ln of x is less than 0 on the interval from 0 to 1. So if you replace x with any value in between 0 and 1, then ln of x will be negative. So that means that f is decreasing on the interval from 0 to 1, and f is increasing on the interval from 1 to infinity. Okay? So that's it. That's all we know. We don't know anything about the concave up or down yet. I'm just looking for you guys to give me directly what do we know because these are the derivatives. Okay? And then let's look at f double prime, that column of f double primes. So if f double prime is this guy, we should know that e to anything is always positive. So therefore 3 times always positive number is always positive. Therefore f is concave up for all x. Same thing down here. E to anything is always positive, always positive. There are no negatives here. 4 plus a positive is positive over, everything's positive. Again, therefore f is concave up for all x. Okay? And then f double prime being ln of x squared. So here x squared has to be greater than 1 for the second derivative to be positive. So the critical points would be x squared equals 1, and this says x has to be greater than 0 anyway, so x has to be equal to 1. That's our critical point for f double prime. Move it up a little bit. Okay, so that being the critical point for f double prime, x has to be greater than 0. If x is between 0 and 1, and I square that number, you know, any fraction squared, like 1/2 squared is 1/4, 3/4 squared is 9 over 16, it's still going to be less than 1. So, in other words, if I replace x with a value that is between 0 and 1, ln of that number is going to be a negative number. Therefore, f is concave down on the interval from 0 to 1, and any number I replace x with that's greater than 1, the second derivative is going to be positive, which means that f is going to be concave up. So I won't write that because I said it, but f is concave down. This is f, concave down on the interval from 0 to 1, concave up from 1 to infinity. And then let's see if I can squeeze this in here. We have ln of x minus 1. So if we set that equal to 0, ln of x minus 1, then ln of x would equal 1. Therefore, x would be equal to, remember that this is an e, e to the first power equals x. So x is equal to e. Okay? So if x is equal to e, that's our critical point for f double prime. And do we still have it on the screen? Yeah. if I put an e there, x has to be greater than 0 if you look back at the second derivative here. So in between 0 and e, I get a number that is less than 1. And so if I replace, let's say, x with 1, because that's between 0 and e, if I use 1 as my test point, test value, that's a 0 minus 1. That means the second derivative is going to be negative on the interval from 0 to e. And then when I replace x with a value that's greater than e, the second derivative then would be positive, because ln of a bigger number than e would be a bigger number than 1. And I subtract 1 from that, and I get a number bigger than 0. So anyway, that just, again, shows us that f is concave down on the interval from 0 to e, and concave up on the interval from e to infinity.